Hello everyone, I'm Muzefa, and in this video we are going to discuss the services available in AWS for setting up your data lake or data warehouse. So, setting up a data lake and data warehouse in AWS can be a great way to deploy a secure cloud-based storage solution. Data lake and data warehouse give the business a flexibility to store structured data, semi-structured data, and unstructured data, and while also allowing them to easily query and process the data. And then in AWS, we have the following services to create your own data lake and data warehouse such as Amazon S3, Amazon Lake Formation, Amazon Redshift, and Amazon EMR. With the right configuration, business can store and access the data quickly and securely while also taking advantages of the scalability, security, and the cost saving that AWS provides. So, the traditional data storage and analytical tools can no longer provide the insights that a business needs. So, that's why a lot of organizations now are moving towards data lake architecture. A data lake on AWS can help you do the following. First one is collect and store any type of data, structured, semi-structured, unstructured data at scale with very minimal cost. The second one is it also provides the security aspect, like it will prevent the unauthorized user to access that particular data. Then the third one is it will catalog that data and will provide you the option to search and find relevant business insights from that particular data. Fourth one is quickly and easily perform new types of data analysis technique on your data set. So the fifth one is AWS will provide you a wide variety of different services that you can apply on your data set to get more insights. For example, you can do predictive analysis, you can perform AI, machine learning, and you can also get real time streaming of different insights. So that's why it is very useful to create a data lake on AWS. Moving forward to Amazon S3. Amazon S3 is the best place to build your data lake because of its unmatched durability, availability, scalability, and compliance related services. And along with S3, we will use other services like Amazon Lake Formation, Amazon EMR, and other stuff. So let's dive into what is S3. S3 is basically a simple storage mechanism provided by AWS to store any type of data. It can be structured data, it can be unstructured data. You can store XML file, CSV file, you can store images, or you can store videos. So, moving towards the benefits of S3. So, the first one is store anything. You can store CSV file, XML files, and JSON files. So, you can basically store anything. And then the second one is secure object storage. So, AWS makes sure whatever you store on AWS, it is secured. So, the third one is natively online and HTTP access. That means that all the data that is present on S3 can be accessed using REST APIs. The fourth one is unlimited scalability. Basically, that means that you can store a lot of data on S3 without worrying about like I cannot store that much data on S3 bucket. You can store like GBs and terabytes of data on S3 bucket. And then the last one is 99.99% durability. So you do not have to worry about data loss or data get corrupted and stuff like that. Moving to the next slide, S3 concepts. So in this slide we will discuss some of the S3 concept, like how S3 works and details regarding that. So to get most out of Amazon S3, you need to understand like few simple concepts first regarding S3 buckets, and then you will get to know about it. So basically, in S3, it stores all the data in form of objects within a bucket. An object is composed of a file and any metadata that describes the file. To store an object in S3, you upload the file you want to store into a bucket. When you upload a file, you can set permissions like this file is available publicly, or this file is only available to authorized user. So this is how it works. And then what is basically a bucket? Bucket is a container where you store all the data, where you store all the objects into it. And then in one bucket you can have like different folders, and then in different folders you can have like different objects. So that is how like S3 works. So now moving forward to data analysis solution on Amazon S3. So the first one is decoupling of storage from compute and data processing. In Amazon S3, like it is a very cost effective solution to store all sorts of data into your bucket in their native format. You do not have to worry about like changing the format of data, processing them, and then adding it into S3. You just store the data in S3, and then you can spin up different elastic compute clouds to fetch the data from S3 and perform different processing on the data. In this way, like all the data is sitting in one place, and then you can spin up like different EC2 instances to fetch data from one particular bucket and then process it. So in that way, like the whole system is very scalable. So the second one is centralized data architecture. Amazon S3 makes it easy to build a multi-tenant environment where user can bring in their own data analytics tool to get the data from S3 buckets, and after fetching the data they will process it and get different insights from it, but the source of the whole data will be at one place. So in that way the data management will be very easy. So the third option is integration with clusterless and serverless services. Like when you have the data on Amazon S3, you can use AWS Lambda, which is a serverless service. It will like fetch the data from S3 and it can perform different actions. And then you can use AWS Athena to query the data which is present in S3 using SQL, and you do not have to worry about loading the data in relational databases. So then the fourth one is using APIs to interact with S3 buckets. So it is very simple. Like interaction with S3 bucket is very simple. You just need APIs to post the data, to get the data, to update the data, and it is supported by all the major third party independent softwares in this data analysis market. For example, like Apache Hadoop and other analytics tools, vendors allow the customer to load the data very easily and very simple process from S3 bucket. So moving forward to a business challenge. So as you know, like the business grow over the time. As the business grow, there are like more files and more data. And then in enterprise systems, all the data is scattered across different servers. And it is very common that employees find themselves like very helpless. They do not know where the data is, like where the data that they are like searching for, in which particular server that data is residing. So in this picture, we can see Kylie. Kylie is asking Gary that my data is scattered all over the place. I never know which server it is on and can never analyze all of it at once. So Gary replies that sounds like what you need is a data lake. It provides a central repository to store all your data in one place. Now, moving forward to Amazon EMR. So business have begun realizing the power of data lakes, and they put all the data into one single repository. And then the next thing is how they will process the data. So for that, Amazon EMR is used. Using Amazon EMR, you can use any open source framework of your choice, and the most popular frameworks are supported by Amazon EMR, such as Apache Hadoop and Spark. Both are supported by Amazon EMR, which will help you to process your data and get meaningful insight from it. So now we will see how Amazon EMR actually works. So as you can see in the picture below, so Amazon EMR can be hosted on Amazon EC2, which is basically a cloud compute service. And then it can be hosted on Amazon EKS, which is basically a containerized service, or it can be hosted on purely serverless service. And then like what Amazon EMR will does is like it will process the data using the open source solutions like Apache Hadoop or Spark, and then will present the data to different services like Amazon SageMaker Studio or Amazon EMR Studio or step functions. So yeah, this is about Amazon EMR. So now moving towards data lake preparation. So data scientists spends like 60% of their time like working on cleaning of data, organizing data, and 19% of the time on actually collecting the data sets. So data preparation is a huge step and is a huge undertaking. So there is like no easy way out. You have to work on like cleaning of data, transforming, collecting, and the whole steps. But you can automate this all time consuming stuff using different Amazon services like Amazon Lake Formation, which we will discuss in the next slide. So what is Amazon Lake Formation? So basically, lake formation makes it easy to set up a secure data lake in days. So a data lake is a centralized, curated, and secured repository that stores all your data, both in its original form and when prepared for analysis. So data lake enables you to break down data silos and combine different types of analytics to gain insights and better guide business decisions. So as you can see in the picture below, that lake formation basically first search and crawls the data, then perform the ETL, extract, transform, and load of data. Then it basically catalogs the data, like catalogs them into different categories, and then adds the security settings. And then like this data, after it is processed, it is added into another S3 bucket. As you can see, like it is fetching data from Amazon S3, or it can fetch data from relational databases or NoSQL databases like DynamoDB or Aurora, and then it will perform all these steps, and you can visually check that. And then it will, after performing all the steps, it will store the output in another S3 bucket. And then we can use Amazon Athena, Redshift to visualize the data. And one more thing, like you can store the output in Amazon Redshift as well. You can store that into a database as well. So it is not mandatory that after lake formation work is done, you have to store that into S3. Moving forward to more details into what is lake formation. Lake formation basically makes it easy to ingest, clean, catalog, and transform and secure your data and make it available for analysis and machine learning. So lake formation basically does a lot of heavy lifting for you, so you do not have to work on like cleaning, managing the data flow and stuff like that. So basically lake formation does that for you. So it is a managed solution, and it does all the work under the hood, so you do not have to worry about like all those steps. And because like basically like creating a data lake takes like months, so using lake formation, as you see in the previous slide, you can like set up the whole data lake in days. So moving forward to setting up a data lake without AWS Lake Formation. AWS Lake Formation is not a mandatory service. Like whenever you have to create a data lake, it is not mandatory that you use AWS Lake Formation. But on the other end, like AWS Lake Formation basically does all the stuff for you. Like it automates many complex and manual steps. So using that will simplify your whole process of uh, basically searching the data, cataloging it, and then the whole data preparation and security aspect. But if you need like more control over the whole data lake pipeline, then you can set it up yourself as well by using like Amazon Athena, Amazon EMR, and Amazon Glue, Amazon Redshift. Like basically EMR will basically process the data. AWS Glue service is used to create the schema out of the data that is present in S3 buckets. Amazon Athena is used to query that particular data. And then when we have the data processed and queried, then we can save that data into Amazon Redshift. This is basically a warehousing service, Amazon Redshift. And then like the whole processed data is stored in Redshift, and then we can query the data from Redshift and use that in different reports. And Amazon Kinesis data firehose are can also be used. Like these are the services for basically streaming of data. Like if you want streaming of data, then you can use Kinesis. So now moving forward to benefits of data lake on AWS. So the first one is it is very cost effective to store data on AWS because it is very cheap. As we have discussed about Amazon S3, you can store all sorts of data, different formats, and it is very cost effective. The second thing is like it is like very good in terms of security and compliance because AWS implements industry leading security and compliance strategies. So you do not have to worry about that. Then it allows you to take advantage of many different collections and ingestion tools to ingest data into your data lake. And then like these services include like Amazon Kinesis for streaming data and AWS Snowball appliance for large volumes of on-premises data. And then the next point is like it helps you to categorize and manage your data, and it is very simple and efficient. Like if you use AWS Glue to understand your data within your data lake, like it will help you like prepare it and like create schema out of your data, and you can then like catalog it, and then it can be queried using different AWS services. So the last one is basically it helps you to turn your data into meaningful insights. You do not have to worry about a lot of hectic process and manual steps. So it does a lot of steps for you and convert your data into meaningful insight. And then you can use like Amazon QuickSight to basically visualize the whole data that is processed and that is output of the whole data lake pipeline. So now moving forward to AWS Redshift. Amazon Redshift is a cloud based data warehouse solution that allows for the storage and data analysis of large amount of data. It is designed to handle the demands of large scale data warehouse and offers a wide variety of features to make data storing and analysis very simple and easy. As you can see in the picture, like it basically like stores the data into a structured form, then it is easy to scale it, and then it can has the ability to store terabytes and petabytes of data. Then you can like query the data using simple SQL, which you are already familiar with. And then once the data is stored, then you can like use that to create different dashboards and different reports. Moving forward to some more details into AWS Redshift. So basically like Amazon Redshift has massively parallel processing architecture that can scale up to petabytes of data and use columnar storage to reduce query times. Redshift also provides a number of advanced features such as compression, data replication, and support for data integration. It also can be used and integrated with other AWS services such as S3, Amazon EMR, Kinesis, and then like it is a very powerful and cost-effective solution for businesses looking to build large-scale data warehouses. Benefits of Amazon Redshifts. So basically, like the performance is 10x than any other data warehouse, and then it is very easy to set up, deploy, and manage. And the next thing is like it is very secure and reliable, and it is very easily scalable and quickly meet your needs, so you do not have to manage it, and it is not very cumbersome to manage it. Like if your needs go up, like you can easily scale up and down. So, moving forward to a business challenge, because a lot of businesses are asking why we should spend a lot of time and money implementing a data lake, because we have already invested so much into data warehouse. So it is like important to know like what is the difference between both of them, or a data lake is a replacement of data warehouse or not. So in this picture, as you can see, Sarah is asking Jessica that I heard that data lake is just a fancy data warehouse. Why should I spend bunch of effort and money on one. So Jessica answers that data lake and data warehouse are two different storage systems. Data lake are not replacement of data warehouse. So to explain you that, like basically, like in this architecture, all the data is first stored into a data lake. That is a single repository to store all your data, structured, semi-structured, unstructured data. And then we use like lake formation or to basically catalog it and process it. And then when the whole data is processed using lake formation or EMR, then after that it is, once the data is processed, then we store that into Amazon Redshift for later querying and creating reports. Or we can store that into S3 bucket or some NoSQL or SQL database as well. But it is a good practice to store the final output into Redshift. When storing massive amount of structured data for complex analysis, we recommend storing data into Amazon Redshift. So basically, like to summarize it, like if you have like simple data, simple files, then you can simply store that into S3. If you have like a lot of files, structured, unstructured files, and the volume is large, then we will recommend creating a data lake on Amazon S3. And in case like if you have like massive amount of structured data and you need to perform some complex data analysis, in that case storing data into Redshift is the ideal solution. So, moving forward to a business case study. So, businesses need a solution that can capture data, locate patterns, aggregate the data, and produce valuable insights. So, the solution must do this in the way d- that does not constrain business resources and talent. The result of this process might be placed into a central location that all employees can process and get benefit from that. So Daniel asked, I need a cloud native solution that will allow me to quickly and efficiently process terabytes of data, storing it for later analysis. Then Monica replies that it sounds like you need a managed platform that supports Apache Hadoop framework such as Amazon EMR in AWS. So, whenever we talk about working with massive volume of data, fast moving of data and processing it, the first thing that comes to our mind is Hadoop. Within AWS, Hadoop frameworks are implemented using Amazon EMR and AWS Glue. These services implement the Hadoop framework to ingest, transform, analyze, and move results to analytical data stores. So, discussing about Apache Hadoop in more detail. Hadoop uses a distributed processing architecture in which tasks are mapped to different servers, and then in different servers we have like different data set, and then some part of the data set is in one cluster, then we have like different clusters, and like the whole data set is mapped in different clusters. Some part of it is in one cluster, the other part is in another cluster. Like we have 10 clusters, so the whole data is divided into 10 parts. All the clusters work on the particular data set they are allocated with, they process it and produce the output. And then when all the different clusters produce the output, then it is reduced into one particular result. And in this way the Hadoop works, and it is very fast in terms of processing the data. So now moving forward to benefits of using Apache Hadoop. Hadoop facilitates data navigation, data discovery, and one-time data analysis. With Hadoop, you can compensate for unexpected occurrence by analyzing large amounts of data quickly to form a response. And then like Hadoop is also very good in terms of uh, basically processing the data. Like it is unlike traditional database, Hadoop can process structured data, semi-structured data, or unstructured data. This includes virtually or any data formats currently available, in addition to natively handling many types of data types such as XML, CSV, text, log files, object, SQL. You can use Hadoop to transform data into different formats that allows to better integration with your existing data sets. It also allows you to store data with or without a schema and perform large scale ETL operation to transform your data. So moving forward to wide selection of solutions. Because Hadoop is open source, so several ecosystem projects are available to help you analyze the multiple types of data Hadoop can process and analyze. These projects give you tremendous flexibility when you are developing data analytics solution. So Hadoop programming frameworks such as like Hive and Pig can support almost any data analytics use case of your application. So now moving forward to implementing the Hadoop with Amazon EMR. So Amazon EMR is the AWS service that implements Hadoop framework. The service will ingest data from nearly any data source of any data type at very good speed. Amazon EMR has the ability to implement two different file systems. So one is HDFS, Hadoop Distributed File System, or Elastic MapReduce File System, EMRF. A file system is a set of organization rules that governs how the files are stored. So we will look into how HDFS works and how it works in the next few slides. So let's start by discussing the Hadoop HDFS architecture. Let's start at the picture, as you can see. So you can see like Hadoop have like multiple different clusters, and the whole workload and the whole data is loaded into different clusters, and then it is processed. So moving forward to the next picture, and then in this picture you can see like we have like different clusters, then we have like name nodes, and then we have data nodes. As you can see in the picture, like mostly we have majority of them as data nodes, and then a small number of servers are basically name nodes that contains the mapping of where the data is actually resides. Clients contact the name node for file metadata or for file modification and perform actual IO directly with data nodes. So moving forward, you can see like whenever we have to make request some data or like update some data, we the client basically requests the name node. The name node then checks like if the client has the permission to access that data or if the data is present and all that, and then the client just give the location of where the data is residing to the client. And then we have like different more examples. We will not cover that, like it will be very time consuming then. So coming forward to Amazon EMR for implementing Hadoop. So Amazon EMR is a AWS service that implements Hadoop framework. And Amazon EMR process begins by ingesting data from one or more data source and storing that data within a file system. If using HDFS, as we have discussed in the previous slide, a file system is stored as an elastic block for storage volume. This storage volume is ephemeral, meaning that the storage is of temporary nature. Like once the process is done, then the storage will be basically deleted. Like then we have free space. Once the data has been like copied into the HDFS volume, the transformation and analysis of data is performed. The results are then sent to the analytical data stores, such as an S3 data lake or Amazon Redshift data warehouse. And basically, what is Amazon EMRF? Basically, these are the two different types that you can choose from. Amazon EMR provides an alternative to HDFS. So EMR file system can help you ensure that there is a persistent source of truth for HDFS, that data stored in S3. When implementing EMRF, there is no need to copy data into the clusters before transforming and analyzing the data as with HDFS. So EMRF can catalog the data within a data lake on Amazon S3. The time that is saved by eliminating the copy step can dramatically improve the performance. So in HDFS, basically like we first copy the whole data into different clusters. As you see, like first we have like name nodes where we have the location of the data, then we have like a lot of data nodes where the actual data resides, then we perform the processing on it. But on the other hand, if you use EMRF, like, you do not have to worry about copying the data into clusters and then processing it. So it will just like get the data from S3 and then process it. So it eliminates the step of copying the data into different clusters. So that increases the performance of the whole solution. So moving forward to the summary. So basically, in this lesson, we discussed various different options available in AWS to set up your data lake and data warehouse solutions, and what are the different services, what are the pros and cons of these services, and in which situation you should opt which service. And then we discuss some of the case studies and what are the possible solutions and possible service that the client can use to resolve that particular business challenge. So thank you so much, guys, for watching the video.